Okay, so now that we've got all our method stubs written out here, we're going to actually start implementing the list. Now in this case, we're going to be implementing a singly linked list, and so what we're going to need to do for that is we're going to need to make an internal class called node that actually holds each of the pieces of data inside each index of our list. And so how we do that is we're just going to call it class node, just like that. And actually we'll make that node generic, so we'll say a generic type of T. And now what this means is anytime we use T inside of here, it's going to refer to this T, which is whatever type we instantiate the node as. So inside of our node, we're going to have two private fields, and that's going to be a data field, and that's going to be of type T, because our data is of type T. And then what we also want is a private field that's of type node T. And that's going to be a pointer to the next node in the list. So basically, each node in the list is going to have an instance variable inside of it, which is the next node in the list. And now we're going to need to actually get and set these fields, so I'm going to write out some public getters and setters for both of these. So we're going to have a public T get data, which returns the data field from this object, so that's return this .data. And then we're going to want a public setter for the data field, so that's going to be void since we don't want it to return anything. And then it's going to be set data, and then we're going to pass in the new piece of data that will be of type T, the new data, and then we're going to set this .data equals the new data. Now we're going to do a similar thing again for the node, so that'll be public node sub T get next, and that'll return this .next. And then again we're going to have a setter. It's void set data. It's going to set the next node, so you're going to have to pass in a node to this function. And then it's going to use that node as the next node for this node. Oops, and we'll call that new node, the parameter there. And then we'll set it as, okay, actually let's call it new next to stay consistent here. There we go. And now we have successfully made our node class, which has setters and getters for our data field and our next field. So now what this means is, since it's of type, it has this generic type T in it, that means now anytime within our code here we can say something like new node, I'll just write this in a comment here so you can see, new node of type E. And what that's doing is saying we're making a new node of type E, where whatever type E is, we're going to use, that's actually what is going in place of T. So we have this placeholder called T, and we're saying actually that's an E. And an E is defined by whatever the linked list class is instantiated as. So hopefully that makes sense for how that node is going to work. And now inside of our linked list class, we're going to need some private fields as well. And so what those are going to be is we're going to have a private field that holds a node sub E, that means that whatever type, again, that means whatever type our linked list is instantiated as. So if we did string, like in this example here, that means E is actually string. And then now we're making a node sub E. That means T is actually just a placeholder for E. So E was a placeholder for string or any other type here. And then T is ending up to be just a placeholder for E in this case. So we're going to have a head node, and that's going to be the first node in our list. And then we'll also have private node E called tail, and that's going to be the last node in our list. And then the last thing we need is a private int called the current size. And we're going to keep this variable updated with whatever the current size of the linked list is. That way, if we ever need to know the size, we can just look at this variable, and we'll keep incrementing that and decrementing that and setting it appropriately in each of our methods as we go through and implement each of those. So now that we have those private fields created, let's make a constructor for the linked list class that initializes those as appropriate. So we'll make a myLinkedList, public myLinkedList. This is our constructor. When we construct a new linked list, we're going to want it to just be an empty linked list. So let's set up our instance variables up here as if the linked list is empty. So we're going to want this dot head equals to null. And we're going to want this dot tail also equals null. There's no head or tail yet because we have nothing in our list. And then we're going to want this dot current size is equal to 0. Okay, so that is the very basics of getting our linked list set up, and we'll continue on with implementing this more in our next video.